Hello, so let us look at some questions regarding quadratics, especially sum and product of the roots. Now, for the first one, we need to find the sum and product of the roots of each of the following. So if I were to just, remind you, the sum was equal to negative b over a, product was equal to c over a. Now, then for a, we get to see the sum has to be negative b, which is equal to negative 5, over a, which is equal to 1. So we know that this simplifies into 5. How about the product? Product is c over a, so we get 7 over 1, which is equal to 7. So we got that. It's not that bad in this case. All right, let's look at number b here. Since this one is not in standard form, so I'm going to move all the terms to the left. So we get 2x squared minus 7x minus 120 is equal to 0. Then the sum becomes negative of negative 7 over 2, which is negative b over a. We end up getting 7 over 2. How about the product? Product becomes c over a, so we get negative 120 over 2. So we get negative 60, becomes our answer. All right, so first two weren't that bad. Let's look at part C. Since we have two quadratic expressions on each side of an equation, so we're going to bring everything onto one side. So then 0 equals, so by subtracting 12x squared, we end up having 3x squared. By subtracting 13x from both sides, then we get to realize that it is equal to plus 3x. By subtracting 14 from each side, then we get plus 3. Now, obviously, we can divide everything by 3, then we get 0 equals x squared plus x plus 1. Now, then what is our sum? Sum is equal to negative b over a. So, negative of 1 over a, which is equal to 1. So, we get negative 1. How about the product? Product is c over 1, c over a, so which is 1 over 1, which is equal to, that's right, that's equal to 1. All right, let's look at the second question here. Find the product of the roots. How do you find the product of the roots? Yes, there was a c over a, meaning c was the last constant. How do you find the last constant? Oh, okay. It comes from here by multiplying these two, which is plus 2. By multiplying these two, we get plus 12. And by multiplying these two, we get 30. So when you add them up, we get 44. But the thing is, a is the coefficient of x squared. So we get x squared here, x squared here, x squared here. So we get total 3 x squares. So hence a becomes 3. So therefore our final answer is 44 over 3 would have been our answer. All right, so let's look at the next question. Number 3. So one root of the equation is 1 here. Find the other root. Okay, wait a minute. How do you find the other root? I don't know what the other root is, so I'm going to call that as r. That means r times 1 is a product of the roots, so which should be then c times a minus b, which is the last constant, divided by the coefficient of x squared, which is a times b minus c. But the thing is, r times 1 is equal to r anyway. I think we got the answer then. The other root must be this one. All right, let's look at number 4. Let p of x be this way, and then where r sub 1 and r sub 2 are the roots of the p of x. And what is this one? So in fact, if I were to make 1 over r sub 1 plus 1 over r sub 2 to have the common denominator, then I can multiply r sub 2 on the top and bottom for the first fraction, and r sub 1 top and bottom to the second fraction. Then we end up getting denominator is r sub 1 times r sub 2. But the numerator now becomes r sub 1 plus r sub 2. Because when you combine them together, but what is the sum? Oh, r sub 1 plus r sub 2 is the sum of the roots, which is negative 7 over 2. And then the denominator is product of the roots, which is c over a, which is equal to 2. So since 2 is common in both ways, I can multiply top and bottom by 2. Then we end up getting these two cancels out, these two cancels out. We get negative 7 over c. And that becomes our answer. All right, let's look at number 5. M and n be the roots of this equation. Prove that this if this one is equal to 1, then this one is true. So let's think about it this one for a second. What is m squared plus n squared? You see, this actually, since both of them are squared, we can think about m plus n squared. But the thing is, if you remember, this one would have had a 2mn plus n squared. You see the middle term. So what we need to do is we need to subtract 2mn so that we could have m squared and n squared left alone, just like over here. Now, then, in this case, what do you realize? M squared plus n squared is equal to 1. From the left side, we realize m plus n is the sum of the roots. What is the sum of the roots? That's negative b over a squared minus 2 times m times n is a product of the roots, which is c over a. Now, if I have to expand this one a little bit further, then we get b squared over a squared and plus 2c over a. So one thing that which we can do here is that we can multiply everything by a squared. By doing that, we wouldn't have any fractions, and then hopefully it will be closer to what we need to prove. Then on the left side, we get a squared is equal to b squared by distributing a squared to both terms. And then minus 2ac. Now, if I want to isolate the 2ac by itself, I can add 2ac to both sides. And then subtract a squared. Then, since these two cancels out, our answer is 2ac. On the right side, these two cancels out, we get b squared minus a squared. And there it goes. Okay, I'll stop here for this homework, and I'll see you later. Bye-bye.